Okay, good day everyone. So we are here to discuss maximum power transfer theorem part 2. So my name is Engineer Reggie Marinay from MPHT Review and Training Center, Marinay's Powerhouse Team Review and Training Center. This is continuation of our direct current circuit part 14. So let's go over with our problem number 6. A 120 volts battery having an internal resistance of 0.5 ohm is connected through a line resistance of 9.5 ohms to a variable load resistor. What is the load current at maximum power transfer? So I already draw the figure. So this is our figure. Okay. So we have a 120 volt source. It has internal resistance of 0.5 ohms. And that is connected through a line resistance. So we have a line resistance here of 9.5 ohms. Then we have a variable resistor RL. So we are asked to find here our IL. So this is our IL. IL here. Okay. So what is our IL? So our IL by Thevenin's theorem. Okay, again, so this is our VTH, then over our RTH plus our RL. And always take note, at maximum power transfer, okay, at maximum power, our RTH is simply equal to our load resistor RL. Okay, so let us find first, we already have our VTH. Our VTH is simply equal to 120 volts. Okay, that is simply equal to 120 volts. Why, sir? Because if we are to open these two terminals, A and B, let us remove our RL here. So we'll be having this circuit. Okay, so this is our 120 volts, so 0.5, then our 9.5 ohms. Okay, so this is our terminals A and terminals B. We have here our VTH. Our VTH is actually our open circuit voltage. If we are to open this circuit, these two terminals A and B, there will be no current flowing here. There is no current flowing. The I here is just simply 0. So if that I is simply equal to 0, it's just like saying that this 9.5 ohm is just like what we have a short circuiting conductor, and also the 0.5 ohm. If we have a short circuiting conductor here, what the measured value of our VTH, if we are to put at terminals A and B, it's just simply equal to 120 volt source. 120. Okay? So, mag-i-equal lang yon. Kasi wala nang kuryente rito. Zero lang yon. Okay? Walang kuryente rito. Kasi nga, in-open mo. Current will never flow in open circuit. For this subject, in direct current circuits, okay, if we have an open circuit, there is no current that will flow. Okay, so let us have our RTH. So our RTH, this is our 9.5 ohms. Okay, and then let us remove and short the two terminals for 120 volt source. Then we have here our A and B. Ito yung point A natin. Ito yung point B natin. Okay, then this is our 0.5 ohm. And then this is our RTH. So, ayan yung RTH natin. Okay. RTH is simply equal to the series combination of 9.5 and 0.5 ohm. Okay. So, that will be our RTH. So, 0.5 plus 9.5 Well, that is simply equal to 10 ohms. That is our RTH. Okay? Then, in our formula, the Thevenin's formula, the IL, we have here our VTH. No? Again, from our previous lesson, our VTH simply equal to our E of the battery, then over 2R. As we see here, okay, if we are to translate this in Thevenin's theorem, this is simply our VTH, then over 2, and then our R simply equal to RL, which is equal to RTH. Okay, so that is our formula. So let us just substitute this. Our VTH simply 120 volts over 2, then multiplied by RTH, which is 10. So our answer here, so this is 20. So this is 6 ampere. Our IL simply equal to 6 amperes. So the answer would be letter C. Okay? Letter C. Isagot natin. Then, let us have now, what maximum power will the battery deliver to the load resistor? What is the maximum power? Okay, we can go directly with our formula for maximum power. Our Pmax, again, what is our formula for Pmax? E squared over 4 RL. Okay, or 4R. What is our E? We have 120 squared over 4. Then our RL simply equal to RTH, which is 10. So this is how much? 120 x squared, then divided by 4, divided by 10. 360 watts. 360 watts. Okay, there you are. Or we can also have this formula, since this is PL, that is simply equal to IL squared multiplied by RL. Wherein we have here 6 amperes squared multiplied by RL, which is equal to RTH times 10. So this is 6 squared is 36 times 10. Still, we have 360 watts. No? Just the same. Okay? So the answer would be letter D. Okay? So we have that. Letter D. Okay, let's go over with problem number 8. Okay, for problem number 8, a barangay power station supplies 60 kilowatt to a load over 2,500 feet. So we have 2,500 feet, 100 square millimeter, 2 conductor copper feeder, the resistance of which is 0.078 ohm per 1,000 feet. The bus bar voltage is maintained constant at 600 volts. Determine the maximum power which can be transmitted. What is the maximum power that can be transmitted? So let us draw first our circuit. So there is a power station. It has a 600 volt supply. Then we have 2 copper feeder. Okay. So actually it is a feeder line. So I will represent RF as the resistance of the feeder line. Okay. Then these 2 terminals, this is where we connect the load resistor. This is the load. Then we'll be having here a current here. That is our current I. Okay, the question here is the maximum power which can be transmitted. What is the P max? Again, the formula for P max simply equal to E squared over 4 RL. Okay? We already have our E, which is 600 volts. What about our RL? We said that the output resistance is equal to the input resistance. Okay? The load resistance is equal to the input resistance. Okay. Let us have first our RF. So how to get our RF? So our RF simply equal to, so it is given in our problem, 0.078. So that is ohm per 1,000 feet. Okay, then we have the distance of the load to the source is 2,500. So we have to multiply it by 2,500 feet. Then we have to multiply it by 2. Why, sir? Because we have to consider the upstream and the downstream conductor. Okay? We have a conductor here, and we also have a conductor here. A single RF represents the upstream and the downstream resistances. So let us then calculate. 0.078 times 2,500 times 2 divided by 1,000, that is 0.39. That's the answer, 0.39 ohm. So this is the value of our feeder line resistance, 0.39 ohm. And remember, this 0.39 ohm simply equal to our load resistance. Load resistance. So let us just substitute here. So we have 600 squared, then over 4, then multiplied by what now? RL. So we have 0.39. So it is equal to what? We have 600 squared, then divided by 4, divided by 0.39. So we'll be having this value. Well, the choices are in kilowatts, so we have to divide it by 1,000. Okay. Again, so we have 600 x squared divided by 4 divided by 0.39 equals, then we have to divide it by 1,000. So our answer is 230.77. Okay, I'll show here that we have to divide it by 1,000. Okay, to make it in kilowatts. So our answer is 230.77. That is our maximum power. Okay? That's our maximum power. And that would be letter A. Okay? That is letter A. Okay, let's go now with number 9. Problem number 9. Okay, number 9. So, two resistors X and Y are connected in parallel. Resistor X having a value of 6 ohms, while resistor Y being adjustable over a wide range. The parallel combination is then connected through the 2 ohm line resistor to a 120 volt DC source. Okay? So we have a 120 volt DC source. For what resistance Y will its power be the greatest? Okay, so what will be our resistance here? Okay, so let us draw now the circuit. We have here We have first two resistors X and Y. I show this to you. Say this is resistor X. Then we have resistor Y. There. Resistor X having a value of 6 ohms. So I will put here 6 ohms. While resistor Y being adjustable over a wide range. So this is adjustable. Okay? The parallel combination is then connected through 2 ohm line resistor. So we have here a 2 ohm line resistor. Okay? To a 120 volt DC source. So we have 120 volt DC source. Okay? Again, we have here 2 ohms here. For what resistance will Y? For what resistance Y will its power be the greatest? So, therefore, there will be a maximum power at resistance Y. There is a maximum power. Okay? So, we have to get here the open circuit resistance or the Thevenin's resistance. Basically, our Y is our load resistance here. Again, the load resistance must be equivalent to the Thevenin's resistance. That is for condition of maximum power transfer. Okay? So, let us remove first our Y. For the meantime, let us remove our Y. I'll show this with you. Tanggalin muna natin. Okay, I already removed Y. Let's say these are the two terminals of Y. And then, I have to remove the 120 volts and the two terminals of 120 volts must be short-circuited. That must be short-circuited. Okay? This will be our RTH. That is our open circuit resistance. Now, what can we say with our 2 ohm and 6 ohm? If this is our ohmmeter. Let's say I am the ohmmeter. I will put here. Okay? See? I will put here in the two terminal. I will hold these two. There is a common node. This is the 2 ohm connected with the 6 ohm. Then another wire of 2 ohm is connected again to the 6 ohm here. So therefore, the two resistors will just simply become parallel. Isn't it? Magpa-parallel yung dalawa. Okay? That will just be connected in parallel. So therefore now, we can calculate our RTH. Anyway, that is the only question in this problem. So we have here 2 times 6 all over 2 plus 6. So our answer would be 2 times 6 then divided by 8. The answer is 1.5 ohms. 1.5. Okay, so this is our final answer and that will be letter B. Okay? Then let's go now to our last problem. Let's have here our last problem. Okay, for our last problem, a variable resistor R in parallel with the fixed resistor 1.25 ohms. The combination is then connected across the 12 volts battery. with internal resistance of 0.25 ohm. Solve for the maximum power that can be delivered to resistor R. Okay. So let us draw our circuit first. So we have a variable resistor R. It's almost the same with our previous problem, or number 9. Okay, so let's say we have a variable resistor R here. Okay, it's connected in parallel with a fixed resistor. So our fixed resistor is 1.25 ohms. The combination is then connected across 12 volts battery with internal resistance. Okay. So we have here a battery. It has an internal resistance, 12 volts battery, and then 0.25 ohm. That is our internal resistance of the battery. Solve for the maximum power that can be delivered to resistor R. What is the maximum power to our resistor R here? So ano ang maximum power dito? Okay? Just the same procedure. Okay? Like what we did before. Okay? We are to get our resistance. Let us get first our resistance here. That is our RTH. Our RTH. So take a look here. Take a look. I will get first our RTH. So our RTH is our open circuit resistance. Looking back at these two terminals, let's say these are terminals A and terminals B. Okay? What is the looking back resistance? So let us have here okay, I will remove the 12 volts, short the two terminals. Then we have here our resistance here. Okay. This is the 1.25 ohms. This is the 0.25 ohm. Okay. Again, just like for number 9, what will happen to our RTH? It is just simply the parallel combination of 1.25 and 125. They are just simply connected in parallel. See? So our RTH now is just simply the product over the sum. We have 0.25 times 1.25. That is the product over the sum. 0.25 plus 1.25. So our RTH now will be equal to what? Okay, 0.25 times 1.25 divided by 0.25 plus 1.25. So our answer for RTH is 0.208. 0.208 ohm. That is our RTH here. That is our RTH. Which is simply equal to the load resistance R here. Simply equal to the load resistance R. See? Ayun, sakto siya dito. Yan. So, equal lang siya This R is equal to 0.208. See? 0.208. Then, to get the maximum power, we have to calculate the current here. Let's say this is our IL. Of course, our maximum power, PL, simply equal to IL squared multiplied by RL. If this is our RL, our load resistance. Of course, we have to calculate for our IL here. What is our IL? Let us have first our total resistance. Now we have a series parallel network. These two are connected in parallel in series with a 0.25 ohm. So let us have now the total resistance of the whole circuit. So it is 0.25 plus, okay, we have here 1.25 times 0.208 over 1.25 plus 0.208. So that is the product over the sum. The combination is in series with the 0.25 ohm resistor. Okay? So, let us calculate. 1.25 times 0.208 then divided by 1.25 plus 0.208. Okay, so that is equivalent to we have that one. Then we have to add the 0.25. So our answer is 0.4. So our answer will be 0.428. Okay, 0.428. Okay, so ayan na yon. Then let us have first our total current. What is our total current? Where is our total current? Of course, that is the current that will be coming from the source. That is always. The total current is the current that will be delivered by the source. Okay? That will be coming from the total voltage, which is the source. That is our total current. So, it's simply by Ohm's law. So, we have here 12 over 0.428. That is equal to 12 divided by 0.428. So that is equal to 28.04, okay, amperes. And then let us get now, remember that this current IT is flowing here, okay. That will be the resultant current by current divider theorem. By current divider theorem. So what do we have here? We have load current simply equal to the resultant current IT. I will substitute. Or, okay, 28.04. Then multiplied by opposite resistance of our IL. Our IL, opposite resistance is 1.25. Over 1.25 plus, again, what is our RL? 0.208. There you are. What is then? 28.04 times 1.25 divided by 1.25 plus 0.208. So that is equal to 24. Is this correct? 24.04 ampere. So that will be our load current, no? So that will be our load current here, 24.04. Now, let us use our formula here. Again, our PL. Here, tingin dito mga kawerpa. Our PL is our IL, 24.04. Quantity squared, then multiplied by RL, which is 0.208. So therefore, our PL is 24.04 x squared times 0.208. So that will be equal to 120.21. So that is our final answer. Okay? And that would be 120.21. That would be letter C. Okay? That is our final answer. Okay? So that's all for today. So thank you very much for today. So that completes our maximum power transfer. Okay? And for our Facebook viewers, so please bear with us. So let me show you some of our presentation for today. Okay? So please listen mga kawerpa para sa inyong lahat po ito. Okay, we have the pre-webinar for October 2020. So this is our series of pre-webinars. Okay. This coming October 10 is the start of our pre-webinar. We will combine our pre-webinar special topics with our restudy electrical engineering. Okay. So as we see here on October 10, so our topic is this is circuit part 16. Actually, this coming Wednesday, we still have our topic, the Y delta transformation for on September 30. Okay, then on October 10, this is circuit part 16. So I think we have the Millman's theorem, for this topic, the Millman's theorem for direct current circuits part 16. Okay. Millman's theorem. Then we have a special topic, Right after this topic, we have a special topic entitled the watercraft electrical system. This is a very nice topic. So I'm inviting everyone, even our electricians, our engineers, or our newly graduate of electrical engineering, electrical technology. Even if you are just a student, I'm inviting everyone to attend to our pre-webinars. These are our set of pre-webinars. Okay. That will be Sundays, every Saturdays and Sundays only. Okay. For this October, all our pre-webinar and our restudy electrical engineering, it will be every Saturday and Sunday, for this October only. Okay. So just wait for the next announcement for the other months. Okay. So for the following month, actually for November, we will move it on a TTH basis for November, kasi magsisimula na yung ating review para sa ating REE, review natin para sa November, This October, ang ating pong pre-webinar, mga kawerpa, is October 10, 11, 17, 18, 24, and 25. Sabado at Linggo na lang po. Free e-certificate for each topic for those who will join in the Zoom class. So if you want to have the e-certificate, we are requiring you to join in the Zoom class. And we require you to open your video, your camera, if you want to join in our Zoom class. You may attend all topics for free, and e-registration form will be given once you join in the Zoom. Okay, so we have a registration on the Zoom. There's no initial registration. Wala tayong pagre-register. First come, first serve basis tayo. No? So join kayo kagad. Lahat ng makakapanood po ng video na ito, iniimbitahan po namin kayo sa October 10. Pero meron pa pala tayo sa September 30, no? This Wednesday, no? So I mean, starting October 10, combined na ang ating pre-webinar at yung ating restudy, electrical engineering. So combine na po 'yon. Okay. So, please, no, first come, first serve. So, dapat po 8:30 to 1, no? So, please allot your time, no? Kung a-attend kayo, i-allot nyo na po itong oras na ito, 8:30 to 1, para makakuha po kayo ng certificate. Sir, pwede ba attenan ko na lang yung second topic lang? The answer is no. Absolutely no. Okay? So, you have to attend 2 topics per day. Okay? 2 topics per day, no? Kailangan mong attenan 'yan. Okay, so then these are our pre-webinars for October. So we have our pre-webinars for October via Zoom. Okay, so this is our fixed topic, no? So monthly, binibigay po namin to mga kawerpa, no? So building wiring installation, practical, electrical design course, industrial motor control, practical electrical estimation course, then power system engineering, no? Or the high voltage engineering course. So this is only 1,500 for each topic. Okay, for student, we give 70% discount. Okay, so it's only 450 pesos. Yan, mura-mura lang para sa mga estudyante natin, no? 450 pesos. Please grab this opportunity. Kasi pagdating po ng November, wala na po yung discount na yan. No? Malamang po, wala na po yung discount na yan, mga kawerpa. No, yung mga estudyante natin, avail nyo na po yan, no? Okay, 70% discount. Then, ito po yung ating mga course outline per topic. So, if you have some inquiry or question, pwede namin isend po sa inyo lahat ito. Early bird promo up to 50% discount mo. Yung aming promo, mga kawerpa, for REE. Kung magbabayad kayo ng cash hanggang October 1, it's only 10,000 pesos, no? Review and refresher na po yan. Yung ating pong online review via Zoom. Okay? So, kung makikita nyo po yung aming pong pagtuturo ngayong araw na ito, no? Kung makikita nyo rin po sa aking YouTube channel, mga kawerpa. So, ganyan po, that's how we are going to conduct our online review class. You will feel that you are in a classroom. Okay? So, mararamdaman mo na para ka rin nasa classroom, no? So, this is a virtual classroom. What we call a virtual classroom. So, ayun. And I would say we have the best online review setup among others, no? Okay, so, you compare that, no, with the other review center. So, our setup. Okay? So, it's only 10,000 for REE. No? Kung magbabayad kayo hanggang October 1, for RME, 9,000 lang. Para sa ating Master Plumber, 8,000 lang po. Kung magbabayad kayo hanggang October 1 lang po yung deadline namin sa aming early bird promo. No? Kung, sir, wala akong pang-cash, pwede ba installment? Pwede po, mga kawerpa. Kaya lang po, madadagdagan po ng 2,000 yung inyong total fee. For REE, magiging 12,000. Sa RME, 11,000. Sa Master Plumber, 10,000. No? You have to pay an initial payment of 2,500 on October 1. Then the balance, it will be on the first day of the class. No? Sa ating Master Plumber, October 11 ang first day. Sa ating REE, dalawang section po ang aming i-offer. Yung Saturday, Sunday class, ang pasukan po noon ay sa November 7. No? Tapos, yung aming isang section, yung MWF class namin, it will be on January 4. Ayan. RME namin, every Sunday po ito, ng 8:30 to 1:30. So, November 29 ang start namin, no? Okay? So, please see our Facebook account. So, nandun po, pinopost po namin lahat ng mga schedules and all the details, no? Ng aming pong mga programs, no? And we have our REE reviewer, no? Baka may mga gusto pong mag-avail po sa kanila, no? Yung mga kawerpa natin nandiyan dyan na nakikinig po sa Facebook Live, mga kawerpa. So, it's only 3,600 pesos. Ito po ang kanyang live na itsura. Okay? So, makikita nyo, mga kawerpa, no? This is a big book. This is an A4 size. So, with complete solution, with calculator techniques na po ito, mga kawerpa. So, makikita nyo po, well explained po, bawat item dito, may mga solutions na po yan. So, in multiple choice, may mga solutions na po. May mga nakalagay na po dito. Complete solution. And for mathematics, meron po tayong calculator techniques. Mga kawerpa, no? May calculator techniques na rin po tayo dyan. Kompleto na po yan, mga kawerpa. Math, ESAS, at saka EE na po yan. Then, for our master electrician, okay, so I have here for our RME, mga kawerpa. Okay, we have 4 RME books. This is worth 2,600 pesos. No? So, yung 4 po na yan. Ay, siya nga pala, nalimutan natin. May promo tayo sa REE, no? Okay, sa REE natin, may libre po tayong libro. This is a Fundamentals of Engineering exam. It contains math, engineering science subject. Meron din siyang electrical subject, no? So, libre po ito, makukuha nyo, mga kawerpa, pag bumili kayo. So, it is actually sa bookstore, maabot to ng more than 300 pesos. No? Before, binebenta ito sa mga bookstore. So, dilibre lang po namin sa inyo to, mga kawerpa. Kung order po kayo ng 4 na books ng aming REE books po namin. Ano po? Then, for our Master Plumber, ito po ang aming book sa Master Plumber po namin, mga kawerpa. Yan. So, ito po siya. Ito po yung live naming libro. No? Kompleto na po yung mga nakalagay po nating notes po dito. Okay? This is actually our lecture handouts na mga kinumbay na po namin, mga kawerpa. No? Nandito na po siya. Mga lectures po namin. Okay. Please subscribe, like, and share my YouTube channel. No? So, the name of my YouTube channel is Reggie Marinay YouTube channel. Okay? So, study electrical engineering the Filipino way. Okay? So, that's it. Thank you very much, everybody. So, I hope you learned to our topic for today. Maraming salamat po. God bless you all. Stay safe.